All right, today we are eventually going to look at factoring, but first I'm going to do one FOIL problem and show you how that we're going to use that to then go backwards. So if we do this mentally, we go x and x squared, add the two terms, so we have plus 2 plus 5 gives us x, and then we multiply them. 2 times 10, 5 is 10. So what we're actually going to do today is we're going to take this and go backwards there and start with this. We're going to the direction to say factor. So let's take that one and just show how we would do that exact same problem. First thing we always look at is this term right here. We want to go back to the first lesson of the chapter where we said write out all the factor pairs. We had 1 and 10, 2 and 5. We could write out all the negatives and positives as well, but honestly, you'll be able to figure that out without doing this. So I would just worry about the pairs. Now we factored, and then we look at this sign. This sign says we want them to add to be 7. Which of these pairs add up to be 7? 2 and 5. So all we then do, x squared breaks down into x and x. We write down 5 and 2, and we need positive 7. So these both need to be positive. Okay. The order could have changed. We could have written it this way. Because 5 times 2 is the same as 2 times 5. But today's, and for the first couple of days, that's what we're looking at. We're going to write down the factors every single time. And then we want them, today they're always going to be adding. Okay? Because see how I wrote it? We are doing adding on our constant terms. Let's just do several of those. All right, so first step, we always look at C. We want the factors of C. For now, I would recommend writing out every single pair. Okay, so we want the pair that adds to be 7. Which pair adds to be 7? 3 and 4. X plus 3, x plus 4. Okay. Do a few more. X squared plus 11x plus 18. So what would our factor pairs be? 1 and 18, 2 and 9, 3 and 6. So we want the pair that adds to be 11. 2 and 9. So we get x, we get 9, we get 2. Again, it's positive 11, so we need positive. So let's do one where we'll have some subtraction signs. So this time we have x squared minus 10x plus 24. So you get factors of 24. 1 and 24, 2 and 12, 3, 8, 4 and 6. So we want them to add to be 10. Which of these will add to be 10? 4 and 6, but we need negative 10. So they will both be negative. So if we need a negative, both signs will be negative. This tells us what signs we need them to be in the parentheses. So x with negative 4, or negative 6. Because what is negative 4 plus negative 6? Negative 10. What's negative 4 times negative 6? Positive 24. So if this is positive, they will be the same sign, whether it's both positive or both negative. Let's do one last one. See if they give us some. Maybe on the tower. Alright. This one kind of goes back over to the other day, but if you don't see that pattern, that's fine. So we want factors of 36. 136. I'm going to go through all of them just because I can. As I actually pointed out, this is one she was able to see, so it's going to be 6 and 6. Are they plus 6 or minus 6? Plus. But this is where we're working on the other day, so they're the same. So what could we then write it as? That's plus 6 squared. So this one was a perfect square trinomial, but let's say you don't remember that. Could we still factor it? Yeah, it's almost easier to do it this way. So this is the first part. We're going to add on the next week and a half with more things added to it. Because obviously with most things, it gets more difficult as we add in more parts. But today's, the biggest key is find your factors, add them to be this middle term, which is b, and then depending on the sign, we'll go from there. So I want, oh, the other thing, let's do one. Where is it? Number 10. One more example. All right, so this one, we want to look at factors of 40. 1, 40, 2, 20, 4, 10, 5, and 8. So we want the pair that adds to be 12. Any of them? So we get 13, 14, 22, and 41. None of them add up to be 12. So our answer, if you cannot do it, it's a prime number, a prime factor. Kind of like this number, 53. Besides 1 and 53, does anything come out of it? So we would say it's a prime number. If none of your factors will work, it's prime. Every now and then you'll get them. But the best way to figure that out is to write them all out. Okay? So what I want to do, starting on 215, we're going to do 11 through 33 odd. 11 to 33 odd. I want to do one more example for the last few. All right, this time our order got switched, but we can still work it. So that's a perfect, that's a square. But we look at this. What are our factors of 25? 1 and 25, 5 and 5. We need the pair that add to be 26. So we would have our x this time is on the right side instead of the left. That's the only change. So 125 plus because this is positive. Okay, so this would get us positive 26. We multiply them, that would get us positive 25. So that's going to be the last couple you will look at, or on the left side versus the right side.